into thinking.
Okay, good morning. So this, I think, when I see there are not many things left, this would be the last session that we want to talk about vectors from analytic approach. And then of course probably you should expect that what is left. We already talked about vectors in analytic form as triples of numbers, and then we learned how to add the vectors in this new setup, how to subtract them, how to multiply a number by a vector, and then we also learned how to dot product them. Yes, so the one is left, and that is the cross product. Yes, today we want to talk about how we can formalize the cross product and analytic approach. So do you remember how I did it when I wanted to go from completely geometrical point of view to analytic approach when I wanted to do the dot product? So let me just review a little bit. So here, assume that you have a vector u with components, say u1, u2, and u3, and a vector v with components v1, v2, v3. And of course, we knew that from the very beginning that u dot v is nothing except norm of u, norm of v, multiplied by the cosine of the angle between two vectors. And then somehow, if you find a connection, how did I go from this definition to this, that u dot v in this new approach would be a very simple combination of these numbers, u1 multiplied by v1, u2 multiplied by v2, and u3 multiplied by v3. We add them and I get a number. That number is the dot product between these two vectors. So do you remember how did I get the formula for this formula here? If you remember that, might be you realize that what we are supposed to do for this new lesson cross product. Do you remember how I went from that? Yes?
I think you used the unit vectors.
Unit vectors, yeah. So we introduced unit vectors. So if you remember, so if I have this coordinate system in 3 dimensions, so if this is the z-axis, x-axis, and y-axis, we had this unit vector here, which I called I hat, and then the unit vector here, which we call j hat, and then this one is k hat. Yes, because we learned that I dot I is equal to j dot j is equal to k dot k using the old definition. Yes, it is equal to 1. Why? Because, for example, this becomes norm of this times norm of that times cosine of the angle between the vector I with itself. Norm of I is 1, so this becomes 1 times 1, and cosine of 0 is also 1, so if you multiply it becomes 1. And then we also learned that any distinct pairs being dot producted, this becomes 0. Yes, why is that? For example, if I dot product I and j, it becomes equal to the dot producting I and k, it becomes equal to the dot producting j and k, and the answer is 0. Why is that? Because any pair of these two vectors are perpendicular, so the angle between any pair is 90, and cosine of 90 is 0, that's 90. And then I needed one more thing. After that, but by the way, what was the property? What was the main property of these unit vectors? If you have any vector called A, which is A1, A2, A3, this can always be written as a linear combination of these 3 vectors. Yes, so I could write it as A1 multiplied by A2 multiplied by j hat, and A3 multiplied by k hat. By the way, what was I hat if I want to write it in an analytic way by components? So I hope that you agree this is 1, 0, and 0. J is what? 0, 1, and 0. And finally, K is 0, 0, and 1. Yes? So this is the summary of what we have here. So do you remember now what I have to do? I have to write U in terms of I, J, and K, and I have to write V also in terms of I, J, and K exactly like this, and then I use the distributive property and the properties of the dot product we have discussed before, and we were able to get this formula. So apparently we have to do the same thing for the cross product. Yeah? So let us discover that together. Okay, so what I need, what I want to do, I want to find a formula for the cross product this time. Yes? But of course, you shouldn't expect a number because you know that U cross V is a vector. So I have to introduce 3 numbers because the answer to this question mark is not one single number like that. It is a vector, and a vector in analytic approach is a triple. Yes? So I have to introduce you 3 numbers. So 1 for the first component, 1 for the second, and 1 for the third. But it is to do this, I have to write something similar for the dot product, this time for the cross product. Yes, so let us discover that. So can you tell me what happens if I cross product these two, or I cross product these two, or I cross product these two? So I mean that I take one of these, cross product it by itself. What do you expect to get?
0.
0 vector, yes, not number. Yes, this would be equal to that, equal to that, equal to the 0 vector. And now this is important to realize. If I cross product I and j, what happens? I am cross producting I and j. So if I want, I don't know if I can show it here. So assume that this is I, this is j. I cross product I and j. So how should I do that? Definitely this becomes a vector. And that vector is perpendicular to the plane of my hand. Okay? This is I, this is j. So in which direction it should be, I need to bend my right hand fingers in a way that turns I to j. And then my thumb will point in that direction. So I cross j is definitely perpendicular to my hand, and it is pointing upward. This is so far. And I have to calculate the length of that, yes?
Depending on which order you multiply them in, you either get k or minus k.
Exactly. And then I am in this case it would be k. Why? Because this is I, this is j. It will be a vector perpendicular to my hand if I can fix it, and then this in this direction. And the only thing is left is to convince ourselves that that is a unit vector again. So how should I do that? So the only thing that is left unknown for me is the norm of this vector. So let me calculate the norm of this vector. Do you remember what was the norm of the cross product? It is the norm of the first vector multiplied by the norm of the second vector multiplied by sine of the angle between I and j, but the angle between I and j is 90 degrees. So the sine of 90 is 1, 1, 1, so the answer is 1. So this means that this vector I cross j is perpendicular to the ground level. It is pointing upward and its length is 1 unit. And then what is the property of k? K is perpendicular to the ground level. It's pointing upwards and it has unit length. So that these two vectors are the same. Yes. So this means that I cross j is k. Of course, as Kevin mentioned, j cross I will be minus k. Okay, but then can you imagine what will be j cross I and what will be I cross, or let me write it in this way, I, j, I, and then I, k. Okay, so I want you to convince yourself by this, the right-hand rule. What is I, no, sorry, I'm making a mistake. J cross K, I mean, and then K cross I mean. Okay, what is J cross I? J cross I. I hope that you can convince yourself easily, because I need to bend my hand in this way, and then it is pointing outwards, and that I is actually coming out. So J cross R and J cross K is I, and what is K cross I? I hope that you agree that this is exactly J. Yes? But I want you to check the directions, please. Yes? So you see, this in this direction, this is pointing out. Yes? This is I, and this is K. And then I want to write K cross I. So I have to bend my fingers in a way that K goes to I, and it points in that direction. And that's exactly the direction of J. Yes? So hopefully you are convinced with these. And the next step is just do the same thing. So now I would write U cross V is equal to, instead of U, I can write U1I plus U2J plus U3K cross, and then I will have V1I, V2J, V3K. Yes? And but we know that this operation has distributive property, so I can just distribute this product here. And then what happens if I cross product these two? U1 and V1s are just scalars, so they can float around. I can pull them out, then I will go and will be crossed by I, which becomes 0. So that is cancelled. But then when I multiply that by that, it becomes U1, but V2, I cross J. And this is on the board. I cross J is nothing except K. Let us continue this. And then I take this one and multiply it by the third term. So it becomes U1 V3. But what should I write? This is I cross K. And the order is important. K cross I is J. So I cross K is minus J. So this turns out to be negative. So you see the formula becomes a little bit complicated. And I will tell you how to try to memorize them. Okay, so up to here. And then I go to the next term. I multiply this by that. It becomes plus, or let us wait for the plus or minus for the time being. So it is U2 V1 J cross I. J cross I is minus K. So this should be minus, and then this becomes K hat. And then I have this one multiplied by that, which becomes 0, J cross J 0. This multiplied by that is U2 V3 with J cross K. J cross K is exactly I, so I don't need to change the sign. And finally, I have these two terms left. So this becomes U3 V1. And then I have K cross I, which is J. So I didn't need to change the sign. I multiply this by that, it becomes U3 V2. K cross J is minus I, and the last term becomes 0. But of course, if I ask you what are the components, you need to tell me what is the I, the component for I, what is the coefficient for I, what is the coefficient for J, what is the coefficient for K. But each one of these appear in two positions, yes? So what I do, I factor, I should have two I's, yes, this one and that one. So this becomes U2 V3, and then I have minus U3 V2 I. Yes? And then what I have, the next one is plus, I have to factor a J out. So let me, I will tell you why. Let me factor a negative sign out as well. Okay, so this becomes U1 V3. It was negative. I pulled the negative sign out, so I put the positive one in. And there is another J component, but it was positive. I am pulling a negative sign out, so it turns out to be minus U3 V1 J hat. And then the other one, I just follow it exactly as it is on the board. So it is U1 V2 minus U2 V1 K hat. Yes? And then of course, if I want to write it in a component form, so let me write it here, so that we should keep it until the end of this session when we are solving the problems. So what happens? The answer to this question is now clear. So U cross V is equal to, the first component is U2 V3 minus U3 V2. The second component includes a negative sign, and then you have U1 V3 minus U3 V1. The next one is, you don't need these pair of brackets here, U1 V2 minus U2 V1. That's it. Okay. Yes?
Why isn't the components, for example, U2 multiplied by U3 equal to U3 multiplied by U2?
Why it is not equal?
Because that should be 0 if it's equal.
Yes, if they are equal, if the vector U and V are equal, each one of, not right now they are not 0, because there is no guarantee that U number 2 and V number 3 are the same.
Okay, I thought it was U and U.
No. But if, of course, you are right, if both of them are U, then all of them become 0, and that is completely consistent, because U cross U should be 0. I understand what you mean, yeah. Okay, so this is a little bit complicated to memorize. Yes? Of course, there is a good order here. So you see, when you are writing the first component, no first component appears. When you are writing the second component, component number 1 and 3 appears. And when you are writing the third component, components number 1 and 2 appear. But this is one rule of thumb. And the point is that the 1, so you see, 1 is absent, so the indices left are 2 and 3. I always start with the 1 with lower index. I put the lower index for the first one first. So it becomes U2 V3, and then I change the order of indices. That is the reason I pulled the negative sign out, so that I can follow the same rule. So you see here which indices should be present. This is the second component, so only indices number 1 and 3 should appear. So I will start U1, V3, and then I replace the indices. And the same thing here. Okay, but the only exception that you have to be careful about is the middle one has an extra negative sign. And I don't know in which direction we will follow, we will come to an agreement, but there is something called a determinant. I just want to tell you not the theory of determinants on matrices right now. I just want to give it a tool for you to memorize things, okay? So if you want to do that, there is some symbol in linear algebra or the matrix theory, and then you have 4 numbers here. This is defined to be, this, if you have a table like that, table of numbers written within these 2 parallel lines, that is called a determinant. A 2 by 2, by the way, if you want to emphasize, this is a 2 by 2 determinant. Forget about this. If we are supposed to follow the matrix theory after that, if we have an agreement for that, then I will talk about them in more formal way. But for the time being, just try to memorize. I'm just introduce them as a memorizing tool. That's it. So just the only thing that you need to memorize is what is the meaning of this. This means A times D minus B times C. That's it. Okay, so this one multiplied by that one. So be careful, not the other way around. A times D minus B times C. So if I introduce you this symbol, what happens here? This can be written as U1, U2 and U3, V2 and V3. Yes? So if you are writing the first component, you don't have first component, you have U2, V3, V2 and V3. Yes? And the next one, if you want to write the second component, the only thing that you have to be careful is this negative sign for that one. Then you don't have the second component. So you have U1, U3, V1, V3. Yes? And then if you want to write the third component, you do not have the third column. You do not have the third components. You will write U1, U2, V1, V2. Yes? Let me convince you of that. If I ask you what is the meaning of this symbol, you say according to what you have defined, it is this number times that number minus this number times that number. And then if I ask you what is this one, U1 times V3 minus U3 times V1 with an extra negative sign. So I don't know which one you prefer. That is something easy, but for me I would never use these things myself. When I want to cross product, I do it like this. Of course I will use the same trick, but I don't waste the time so many times. I would just write U1, U2, U3 in my head or in a scratch paper, V1, V2, V3, yes? When I want to write the first component, I hide the first component, I multiply like that. Yes? And if I want to write the middle one, I just hide the middle one and I do like that, but I have to keep in mind that I have an extra minus sign. And when I want to write the third component, I hide this one and I do this trick. Yes? So that's up to you, but in which way you memorize, but you have to be able to use the formula. Is that okay? So you see that a little bit involved problem, but the problem is the formula is not that straightforward as a dot product, but of course you could expect because you need 3 numbers rather than 1 number. Okay, so that is the formula that we have. So let me just solve some problems for you. Yes, it's now probably very easy. It is more or less usable here. Okay, so example. A very, very simple example. What is left is not that hard at all, actually. So let U be this vector. U be vector 1, 1, and 0. And V be this vector, 0, minus 1, and 1. Determine the norm, the magnitude of this vector, of the vector 2U plus V cross product with U minus 3V. So we want to calculate the norm. Here, in analytic approach, we actually can calculate things precisely. So I have given you 2 vectors, and I am asking you to determine the norm of this vector. You can view this problem from 2 different ways. Either, so you can combine. I don't know. Let me write method 1. They are not actually 2 different methods, but let me write this. So one way, because you see that you know how to find components for this, you know how to find the components for this. And then today we'll learn how to find the components of the cross product. And if you want to calculate the norm of a vector, you need to have the components and then use the formula for the norm of a vector. Yes? So what I want to do here, let me calculate 2U plus V. So this means that I have to multiply U by 2 and add V to it. And then let us do it in our head. So 2 times 1 is 2 plus 0 is 2. 2 times 1 is 2 minus 1 is 1. 2 times 0 is 0 plus 1 is 1. So these are the components of the first vector. I can have the second vector. So u is 1, 1, and 0 minus 3 times 0 minus 1 and 1. So this means 1 minus 3 times 0 is just 1. 1 minus, this becomes positive 3, and 1 becomes 4. And then I have 0 minus 3, so it is minus 3. Yes? And then what I do, I would say that this would imply that 2u plus v cross u minus 3v. This is the new lesson. And I told you that I usually write 2, 1, 1 in a scratch paper or whatever, like this. Yes? And then I would say that, okay, because I want the first component, so I want to use the new formula that we discovered today. So I take this away and just do this cross way of calculating. 1 times minus 3 minus 7, minus 3 minus 7. Yes? Is that understandable? This times that minus this times that. And then for the middle one, I put the minus sign not to forget, and then cover the second column and do the same way. So it is minus 6 minus 1 is minus 7, but I had an extra 7 minus sign, it becomes positive 7. For the norm, it doesn't matter, but you should be careful. And finally, I cover the last column and I multiply this, and this also becomes 7. Is that understandable? Yes or no? Okay, and now, therefore, I am going to calculate the norm. The norm of this vector is what? Forget about the name. I have 3 components. I want to find the norm. So it is minus 7 squared plus 7 squared plus 7 squared. So it is what? 7 square root of 3. Yes? Because it becomes 3 times 7 squared. 7 squared goes out, 3 will be left. Yes? So that is the length of this vector. Is this understandable? Okay. Now another method, of course, you can combine geometrical point of view and analytic approach. Yes? So method 2, it doesn't matter how do you want to do it. You can start cross-producting them. For example, I just cross-product that one in my head. You see, this one cross that one is what? This one I can distribute. This one cross-product, that one is 0. And then this one cross-product that one. So let me write it here for you. So 2u plus v cross-product with u minus 3v, this becomes, this cross product by that one is 0, this cross product by that one is minus 6, u cross v, this one cross product by that one is plus v cross u, you have to pay attention to the order, and this one cross product by the last one is again 0. And then what happens? U cross v and v cross u are not the same, but they differ only by a minus sign. So I interchange that, and the price that I have to pay is to make it negative. Yes? And then what you see, this is minus 6 of them, minus 1 of them, so it is minus 7 of them. Yes? Now the question mark in the problem is the norm of this vector, but this vector is always equal to that vector, so I can calculate the norm of the last vector instead. Yes? But do you remember, if a number is multiplied by a vector and I'm interested in the norm, this becomes absolute value and it's pulled out, so it becomes 7 norm of u cross v. Okay, I wrote a lot, but if you are quick in these things, I think this method is faster because you really don't need to write. You can immediately understand. If you multiply that, you will get this one. Okay, and then this means that instead of finding these new combinations and then cross product them and then find the norm, I can immediately find the cross product of these original vectors and find the norm. Yes? So now I told you that what should I do for u cross v? I write the first one on top. The order is important actually. The second vector below. Okay, let us practice. For the first component, I hide this, and this becomes 1 minus 0. For the second component, I put a negative sign, and I do the same thing. So 1 minus 0 is 1, and there is a negative sign minus 1. And for the last one, it becomes minus 1 minus 0, so it is minus 1. Yes? And then the norm of this vector, so the norm of this vector is square root of 1 plus 1 plus 1 square root of 3. So the question mark is 7 times this number, which is exactly the number we got. So that is up to you in which way you want to do it. Okay, so let me give you another problem. Any questions here? So example, I want to wait for you a little bit so you can also refer back to your notes. That's also helpful for the coming quiz. So I want to wait for you to solve it for me and then we can continue. Actually, there is nothing left. Yeah, let us see how it goes. So let A, the point A with coordinates 2, 2, 4, B with coordinates minus 1, 0, 5, and C, the point C with coordinates 3, 4, and 3, be vertices of a triangle. Of the triangle ABC. Okay, so determine the area. No. Determine the height let me write this one. By the way, I think you still remember from the detour to Euclidean geometry, yes? So when I say H sub A, what do I mean? If you have a triangle ABC, I told you it is common to call this A, and the height which corresponds to this is called H sub A. Yes? So we want to find the height. Okay, I want to pause recording. I want to give you time to practice. Of course, it is better, I think, to refer back to your notes. If you remember, at some point we were talking about the areas of a parallelogram and the area of a triangle, which was connected to the cross product in somehow. So if you have forgotten, that is a good excuse to go back and review and try to solve the problem. Okay? I want to pause the recording and wait for you. So the people at home, I don't know how many of you are there. So only Dima. So Dima, if you want to write the numbers, please write them down, because when I pause the video, we will not be able to see that. Okay. Dima, did you write them down? So I want to pause recording. Okay.
Yes.
Okay, thank you. Yes, what's the answer?
The root of 48 divided by 6 is the height.
The number that I see is not that number. 48 by 6, you said?
Yeah, the square root of 48
so
by
if
6.
you simplify that, it becomes how much?
That's not at least the number that I see here. Might be I have done some mistakes. I don't know. Let us see. Any other? So what was your strategy?
So we calculated first we created two vectors. We chose AB and AC.
Okay, so that's correct. Let me follow yours. So AB, you are saying that you are. So this is a problem not in vectors. That's just a pure geometry. But you want to use vectors to solve it. So what you are suggesting is that you write a vector AB. Yes. So the points are given. You want to make the components of AB. Is that yes? And then how do you write it? What is the rule? So what should I write? The numbers. How do you find the numbers?
We wrote for but we wrote 3 for the first component.
How?
We took the distance.
That's not distance. Remember this. I told you that if you have two vectors, if you want to write a vector, what you have to do, you have to take the final points, the components of the final point, and the coordinates of the final point, and minus the components of the initial point. That's not a distance, because components can be negative as well. Yes. So this is probably your mistake, but your method is correct.
Yeah.
I think AB. It doesn't matter if you write BA or AB, but because you have written AB, you have to also respect the order and write the coordinates of B minus 1 minus the coordinates of A, which is minus 3 here. And the same thing here, 0 minus 2. It's a very simple rule, but I told you it's very important. 0 minus 2 is minus 2, and then 5 minus 4 is 1. This is what you get for AB. Yes? But of course, if you have written the other way around, it is not sensitive. Your answer shouldn't be sensitive if you have written 3, 2, and minus 1.
Exactly.
But if you have written 3, 2, and 1, then that is sensitive.
Oh, I think we broke.
Because if you have cared about the distances all the time, might be you got all of them positive. Yes? So be careful about that. Okay, and then what to do again? It might be you said that I want to write AC as well. Okay, so AB, so I'm working with this vector and that vector. AC, the same rule. The coordinates of the final point minus the coordinates of the initial point. So 3 minus 2 is 1. And then 4 minus 2 is 2. 3 minus 4 is minus 1. Okay, then what? So assume that now you were able to calculate these vectors.
And now we cross product them to get the area.
Now that's area 2 times the area.
And divided by 2.
Yes, that's correct. So I cross product them. So this means that AB cross AC is what? And that is good that I have written them beneath each other now, so I can just immediately use that trick. So the first component, hide it and just do it in your head. Minus 2 times minus 1 is 2. 2 times 1 is 2. Subtract them. The first component becomes 0. Yes? It might be you are confused with these calculations as well.
No,
so you hide the middle one and you multiply this by that, it is 3. Multiply this by that, it is 1. Subtract them, it becomes 2. But the middle one has an extra negative sign. So it's negative 2. And then the last one finally is minus 6 plus 2 is minus 4. Yes? And then if you remember the previous lessons, the area, which we denote by S, is 1/2 the norm of this vector. This is not a new lesson, that was the previous lesson. We had it before, and we also proved that. So this means that this becomes 1/2. If I want to calculate the norm of vector, I need to have the components. I have it, so it becomes the square root of this one to power 2, this one to power 2, and this one to power 2. So then it becomes 16 plus 4 is 20. So it becomes 1/2 square root of 20. And then square root of 20 is 4 times 5. Square root of 4 is 2 is cancelled. So it's just square root of 5 area units. So that is the area of this triangle. But the area, of course, they could ask you the area, that is done, but they have asked you for the height. But then you also know a very elementary trick. So the area is equal to 1/2 of the base multiplied by the height. You know the area. If you can calculate the base, the length of the base, and then you can calculate the height as well, yes? So what should we do? We can calculate actually the length of BC, yes? I want to find BC, and that is the distance formula. So do you remember the distance formula is a square root of the difference between x coordinates squared, the difference between y coordinates squared, the difference between z coordinates squared. And then if I calculate this, so the difference between x coordinates, -1 minus 3 is -4 squared is 16. The difference between y coordinates is 4 squared, 16 again. The difference between z coordinates is 2 squared is 4. So this becomes 36, it becomes 6. So BC is the 6 length units. And we also have another formula, which is an elementary formula. It's 1/2 the base multiplied by the height. I know this from another method. I also know this, and that is my question mark. So I should be able to find that. So S is a square root of 5 is 1/2 multiplied by 6 multiplied by the height. This becomes 3. So the height is square root of 5 divided by 3 length units. Yes? Yeah, but that method is completely correct. Good. I want to solve this problem and from using dot product. That is more important, I would say. The reason that I would say it's more important because if you go to higher dimensions, you can immediately extend the dot product, yes? If instead of having 3 numbers, yes, if I have 4 numbers, and if I ask you what would be your opinion about dot producting quadruples, it is easy, yes? You say that I will multiply this by that, multiply this by that, multiply this by that, and multiply the 4th components and then add them. So at least algebraically, it is easy to extend them, yes? But it turns out that the cross product is not that easy to generalize for higher dimensions. So if you can solve a problem using the dot product method, it is superior in more advanced mathematics. So that's what I'm saying. That's completely okay to solve it using the cross product that we have here. But can you tell me, how can I solve this problem without actually using the ideas of the cross product? And then the lesson will be finished after that. So how can I find the height? By the way, it's more straightforward and more logical. You want to find the height here. And of course, if you want to think about it, think only about vectors. So that the idea is to work with the projection vector. Yes, that projection vector is very important. So remember how to use it effectively. So let me write, for example, let us concentrate this time on BA. It might be easier to imagine. Of course, there is no difference here. So here I have B, here I have A, and here this is my H. and then this is my BA. So if I ask you what is BA, you can immediately answer. BA is 3, 2, minus 1. If I ask you, so and this, let us call this vector BC. This vector BC. Yes? And now if I ask you what is BH, what do you say? You see, BH is the projection of BA onto BC. Yes? So BH is the projection of the vector BA on vector BC. I don't know if you remember the formula, even if you don't, but the point is that you understand the connection, and if you have forgotten the formula, you can refer to the formulas. So the projection of U on V, if you refer to your notes, you will see this becomes U dot V divided by the norm of V squared times V. That was the formula we got. If you have forgotten, you can, but if you understand the connection, that's enough, of course. You can refer to the formula. So what happens, by the way, in Koteho, you are not allowed to use the formula, so you have to memorize them at the end, okay? In 2 or 3 months, if you go there, or even any other universities probably here. So what should I do? This is playing the role of U, this is playing the role of V. So then it becomes BA dot BC divided by norm of BC squared BC. That is BH. Yes? Okay, let me calculate this one. This is very instructive. I want you to learn this method as well. So what happens here? Do I know BA? Yes. I also need BC. So let us calculate BC. BC is the final coordinates minus the initial coordinates. 3 minus 1 is 4. 4 minus 0, 4. 3 minus 5 is minus 2. Yes? And now you see I don't have any cross product involved. I have dot product. Dot product is easy to work with. So let us do it in our head. This is 12. This is 8. Becomes 20. And then this is 2, 22. Yes? And then BC squared. 4, 16. 16 and 4. It becomes 20. Yes? And then I have BC. 4, 4 and minus 2. But let me simplify things. So this becomes 11 over 10. Yes? And then I pull a 2 out. 2, 2 and minus 1. Simplify this 2 with that one. I can write 1 over 5, 2, 2 and minus 1. Or if you want, of course, you can multiply. Let's multiply. So then it becomes 22 over 5, 22 over 5, minus 11 over 5. So you see, if I ask you what is this, this is just vector BH. This is vector BH. Yes? But now tell me, my point was not to find vector BH. My point is to somehow find the length of AH. So how should I do that now? How can I write this vector? This should be very, you should be very quick in this case. AH, how AH is related to these two vectors? Yes?
BA minus BH.
Exactly. So HA is BA minus BH. Yes? So BA minus BH. And what is BA, by the way, is this. So this is 3, 2 and minus 1. This is why BH becomes relevant in this problem. And we already calculated that. So it's minus 22 over 5, 22 over 5, and minus 11 over 5. And then we calculate it in our head, yes? So what happens? 3 minus 22 over 5. So what's the answer? 15 minus 20 is minus 7 over 5. And then 2 minus 22 over 5 is how much? 10 minus 22 is 12. over 5, and then minus 1 minus minus 11 over 5, which is plus, and then it becomes 6 over 5. But that is a little bit strange.
Shouldn't the second one be positive?
No.
10.
22
Oh,
over
no,
5
no,
is
no.
bigger than 2, yes?
Yeah, I'm sorry.
Yeah, no
thought it
worries.
was
But
still
the numbers are a little bit strange because we already know the answer. So if I have done everything in my calculations right, the length of this vector is wanted. Because HA is the vector, but I want to find the length. So let us calculate this here. So let me clean this and write it properly here. Okay, so how should I calculate the length? HA, which is wanted, is equal to the norm of HA, and then it is square root of, this number to power 2 is 49 over 25, 144 over 25, 36 over 25. So this becomes square root of 25. This one and that one is 180. Yes? And 229. And that's the problem, yes? I have to see where I have made a mistake. Am I right in this calculation? So 36 and that one is 100. Oh, yes, 180, 229. But that cannot be simplified. So, yeah, this is very important actually to detect the error. Do you see any flaws in my calculation? So let me quickly double check that. So BA means 2 minus 1 is 3, 2 minus 0, yeah, that's correct. And BC is this minus that one is 4, 4 and minus 2, that's correct. And then BH is the projection of this vector onto that vector. So it means that I have, according to the formula, I have BA dot BC divided by that. That is also correct. Okay, BA dot BC is 12 here and 8 here. So far 20. And then positive 2 here. So 22. And then BC is 60. I don't know why I wrote 20. So 16, 4. It's 36. Yes. I don't know. Why don't you check my calculations? Yes. So 16 plus 16 plus 4. I don't know how I wrote 20. So what is that one now? 36. Okay, it will affect all the calculations now. Yeah, we have to do it anyway. Let us see. So, let me calculate this one. So this time, if you don't mind, I pull a minus 2 out. A 2 out. It becomes 18, and then 11 over 9. 2, 2, and minus 1. Do you agree with me or not? Yes?
Yeah.
Because first I simplified by 2, 11 over 18, then I pulled another 2 out. That 2 coming out will be simplified with 18, and it becomes 9. That hopefully is correct. And then HA is equal to BA minus BH. So what is BA? BA is this 3, 2, minus 1, and minus that number. So let me multiply that in. 22 over 9, 22 over 9, minus 11 over 9. And if I subtract them, 27 minus 22, 5 over 9. And then 18 minus 4 over 9. And then this is 11 over 9 minus 1, 2 over 9. Yes? And now, these numbers I have to calculate. Let us see it works this time. So this is 25 over 81. 16 over 81,
But
4
the
over
last term
81.
be
Wrong again?
negative.
Why it is negative? Let me check.
There we go.
So 2,
Minus.
it's minus, yes, because 2 minus 22 over 9. 22 over 9 is greater than 2, so definitely it should be negative. Okay, let me see if this is working or not. So it is 81 now, 20, 45. So this becomes the square root of 45 over a square root of 81 is 9. But the square root, yeah, that's correct. Because 45 is 9 times 5 divided by 9. Square root of 9 is 3. Square root of 5 divided by 9. Then it becomes the square root of 5 divided by 3. So that was the idea was correct. But you see, I would consider that a more advanced, so if you go to higher dimensions, and if you imagine a triangle in hyperspace, you still can calculate the height using this dot product, but not with the cross product as easy. So I just want you to learn both of these methods. Okay, so actually the lesson of this analytic approach for vectors is finalized here. Now we can think a little bit about from now on what we want to continue in this course. Okay, but let me just pause the recording and we can discuss, or you can also think for later. Okay, I stopped the recording. Thank you.